All right, let's take a look at these Newton's second law problems. We've got two of them that we want to do. The first one is about a truck, and the truck has a mass of 25,000 kilograms. It experiences a force of 75,000 newtons, and we want to find out what the acceleration is. So let's do this first one. So the force applied to the truck is 75,000 newtons. The mass of this truck is 25,000 kilograms, and we want to find out what the acceleration is equal to. Newton's first law reads F equals ma. So we need this equation here to read A equals, because that's what our unknown variable is. So this one, there is a triangle trick for it. And if we do our triangle trick, we just have to put F on the top. We have A and M down here. And we can see that if I want A, if I cover that up, I've got F on top of M. And that will give us our equation for Newton's second law to find the acceleration. A equals F over M. So there it is. Now let's put the numbers in. So we've got our 75,000 newtons, and we divide that by our 25,000 kilograms. And we see that this is just going to give us 3. And because we're looking for acceleration, the units will be meters per second squared. So this is number 1. We have one more problem to do as an example. This one is a crate. The crate's being pushed along the floor. There's a force of 450 newtons that's applied to it. However, in this case, there is a frictional force of 75 newtons holding it back as it's sliding across the floor. And again, we want to find the acceleration. If we list everything, again, we can see that the mass of the crate is 210 kilograms. There's a force that's applied, I'll use FA for this, of 450 newtons. And we also have a frictional force of 75 newtons. We want to find the acceleration. Now for this problem, because there's more than one force in the direction that this thing is moving, we should draw a free body diagram. So to do that, we'll draw the dot for the crate. I'm going to actually give myself a little bit more room right here. So we've got gravity pulling us downward, and we've got the normal force pushing back up. For this crate here, we have acceleration in this direction. We also have an applied force in the same direction as our acceleration, but we have a smaller frictional force that opposes that. So for this problem, I only need to look at the x-axis. I only need to look at FA and FF because that's what's parallel to our acceleration. Gravity and the normal force are not causing acceleration. They're balanced in this case because the crate is staying on the floor. So what I want to do then is I want to sum up all the forces, sigma F, on the x-axis. So the one that's pointing in the positive direction is the applied force because it's pointing to the right. Frictional force is pointing to the left. So it's this equation that gives us the ability to find what the net force is equal to. So our net force on the x-axis will be the applied force, which is 450 newtons, minus our frictional force, which is 75 newtons. And this gives us 375 newtons. So this is what the net force is equal to, and that's what's responsible for accelerating the cart. So now I can use Newton's second law, A equals F over M, the same as we did in the first problem. So you can use the triangle trick if you like. Let's make this a little neater. But for this one, I don't want just any force. I want the net force in the x direction. So now we can solve this problem because we'll put in our 375 newtons. We'll divide that by our 210 kilogram mass of the crate. And now we get 1.8 meters per second squared. So this is now the acceleration that we figured out for the crate as it's sliding across the floor. So for this one, we needed a couple things. We needed to draw the free body diagram. The free body diagram allowed us to sum up the forces so that we can find the net force. And then using Newton's second law with that net force, we can find what the acceleration is equal to. 2 examples of Newton's second law. Good luck on the other problems, and I will see you in class.